Hello everyone, welcome to our YouTube channel Electronics Maddie. In this video, I'm going to demonstrate simulation of fuzzy logic based boost converter in MATLAB Simulink. In case you haven't subscribed to our channel, please do subscribe to it so that you'll be getting the videos that we post regularly. Alright, let's get into our topic for today. This is a MATLAB model of fuzzy logic based boost converter. If you carefully observe, we are using a fuzzy logic controller in the closed loop system. I made a couple of videos with respect to open loop simulation and design of a boost converter and closed loop simulation of boost converter using PI controller. So over here I am using fuzzy logic controller instead of a PI controller in order to establish a closed loop system. The reason is because the steady state response and the peak overshoot is much lesser in comparison with the PI controller. Consequently, one more important aspect is that fuzzy logic controller can be implemented based on human logic. So whatever logic that comes into your mind, you can implement that and directly that will be giving the output based on the logic that is defined. And that is why these type of controllers are popularly used in MPPT techniques, and it is gaining popularity in a lot of renewable energy applications. So now there should be a logic that is to be defined in the fuzzy logic controller, right? So what is that logic? So this is called as fuzzy logic. We will define what has to happen within the fuzzy logic controller, and consequently the fuzzy logic controller will provide the desired output. So the inputs for the fuzzy logic controller, so there are two inputs, the error and the change in error. So the change in error is basically the error that is holding the previous value of the error. So how do we do that? I'll explain you in MATLAB. So these are the two inputs. So PB stands for positive big, PM stands for positive small, positive medium, PS stands for positive small, Z stands for 0, NS stands for negative small, negative big, and negative medium and negative big. So the same holds good over here as well. So whenever there is the actual value of error and the change in error is with respect to these values. So if there is positive big and negative big changes, then consequently the output should be equal to 0. These are the duty ratio that are defined over here. So this basically happens to be the duty ratio that will be given to the MOSFETs. So for example, if you carefully observe one point, when it is positive big, negative big, or positive medium, negative medium, so the diagonal values are equal to 0. The reason is because if there is positive big changes in the actual error, then the changes in the previous value of the error will be negative big, and consequently positive big and negative big will be cancelled out, and it will be equal to 0 because I'm using a summing block in the MATLAB. So that is why all these values are 0. However, if there is another example, if you need to consider, if there is positive big and negative small, you will be considered the duty ratio percentage to be equal to 50%. So if there is positive medium, so positive medium is comparatively lesser than positive big, isn't it? And you're doing it with respect to negative small, comparing these two values. So I'm considering a slightly lesser value, say equal to 5% of the duty ratio. Now again, positive small, negative small will cancel out, it will be equal to 0. 0, basically negative small will be greater than 0, that is why it goes to the negative value. So negative is minus 5. Negative small, so basically it will again add the negative values, it will be equal to minus 50. I hope the logic with respect to defining the duty ratio over here is understood. So these are the values that are very important, and this is what we will be entering in the fuzzy logic rule in fuzzy logic controller. So be very careful, keep a note of this particular table or take a screenshot of it. This will be pretty handy while entering the values in the fuzzy logic controller. So all right, let's go to MATLAB and start our simulation. So all right, here I am in MATLAB. So at the first place, before getting into the Simulink window, let us type fuzzy and click on enter. So you will have to wait for some time. So you get a pop-up like this, which is called as fuzzy logic designer. Over here, you have to design the fuzzy logic controller. That is the most important aspect. Once you design fuzzy logic controller, remaining things is pretty much straightforward. You will be able to do it. So at the first place, let us start off with defining this particular controller. We will be requiring another input. So go to input and add variable and then click on input over here. So once this is done, now I will be changing the input names. So basically this is called as error, and this is called as change in error. So you can consider it as change in error or change error. So consequently the output will be duty ratio, so you can type it as duty. So this is done. So we have named the input and we have named the output. So double click on the error block. So you will be getting something like this. You can click on any of the three inputs or the output block and you will be getting this window. So what is this over here? So here is where you have to define the membership functions. So basically you had something like this, isn't it? So what we have to do, you have to click on remove all membership functions. So membership functions basically are basically the signals that will define the logic that is to be held with respect to the circuit that we are building. So click on edit and add membership functions. So let it be the waveform be triangular in the same fashion that it is. So we will be requiring 7 membership functions. So select 7 and consequently you'll be getting membership functions in this particular fashion. Major things that you have to do, rename all of them in this particular fashion. Negative big, so you'll start off with negative big, then you will be having negative medium, so nm, then click on this, change it to be equal to negative small. So once that is done, change this to be equal to 0, that is basically z. Change this again to be equal to positive small. So we are going in the same hierarchy and that will be followed for the next input as well. Positive medium, then we will be left out with positive big, so PB. So once we have entered all these, so you can go into the next input, that is the change in error. So over here again, go to edit, remove all membership functions. So let us add membership functions. We need 7 membership functions. So click on OK. So these are basically signals. So that is from a specific range. So when there is coinciding values between these two errors, the duty ratio will be decided. So that is how the logic works. Now again, over here, change in error, we have to give the values of the individual blocks. That is negative big we'll be starting off with, then we will be requiring negative medium, then you will be requiring negative small, then you will be requiring 0, which is in the middle, which is represented by z. Then we will be requiring positive small, so enter p, yes. Then we will be requiring positive medium, enter pm. Then we will be requiring positive big, so pp. So once this is done, the next step is to click on output, that is basically the duty. So remove all the membership functions again. We will be defining our own rule over here. So add membership functions again, let it be 7. So click on OK. So done. Now we will be entering the values over here in duty ratios. So we will be starting off from -100 and click on this. It will be -50 and this will be, so you can change over here. This will be -50 and this, select this and change it to be equal to -5. This will be equal to 0. This will be equal to +5, again in the same hierarchy. So this will be equal to +50 and this will be equal to +100. So once this is done, you can cross check if all the membership functions with respect to input and output variables are defined. So you have all the values entered. Again, with respect to this, you have all the values entered with respect to the output. So now you can close this window. You'll be left out with this window, error, change in error and duty. So now we have to define the rule. So how do we define that? Double click on the untitled block and you will be arriving at this window called as rule editor. Over here we will be defining the rule. So now keep the reference of the table that I had already shown you. So with respect to change in error, so this is basically the actual error. So actual error, if it is say equal to PB, and if this is say equal to NB, so I'm basically going on with respect to rows. So when this is NB and this is PB, what should be the output? So AND logic should be used and the output should be equal to 0. So click on 0 and click on add rule. So now let me keep this constant because with respect to first row it is always NB. Now let me only change this. This should be PM and consequently this should be -5, add rule. So once this is done, now this should be PS. So the change should be -50. So add this. Click on add rule. Let it be AND. So when both of them are in these values respectively, the duty ratio in percentage should be this much. That is what we're trying to do. So once PS is also added, our next block is 0. So click on 0, and this value should be equal to minus 100. So add rule. So once this is done, next block is ns, and the change should be minus 100 itself, so add rule. The next block is nm, the change should be minus 100, add rule. The next block is nb, the change should be minus 100, so add rule. So once this is done, we'll get into our next row, that is basically nm with respect to change in error. So basically keep this change in error to be equal to nm, and now we will be changing these value, that is the error values over here. So again, this will be starting off from pb, and the value should be equal to plus 5, add rule. So this should be equal to pm, and the value should be equal to 0, add rule. So this should be equal to ps, the value should be equal to minus 5, add rule. This should be equal to 0, and the value should be equal to minus 50, so add rule. This should be equal to ns, the value should be minus 100, add rule. And then this should be equal to nm, the value should be equal to minus 100, add rule. And this should be equal to nb, and again the value should be equal to minus 100, so add rule. So we have completed with respect to 2 rows. We still have 5 more rows to be done in the similar fashion. Now this should be changed, the change in error should be changed to ns. Consequently, the values with respect to error, that is, it starts off from pb, the value should be equal to 50. So start off from this point, click on add rule. So again this should be equal to pm, and click on the value to be equal to 5, add rule. This should be ps now, click on 0, and then add rule. This should be 0, and the duty ratio should be minus 5, so add rule. So once this is done, negative small, the duty ratio should be minus 50, add rule. This should be negative medium, and the change should be minus 100, add rule. This should be nb, the change should be minus 100 again, so add rule. So we've done 3 rows. The next row is with respect to 0, and we'll be starting off from pb again, and the values will be from 100. So click on add rule. Then we have pm, the value should be 50. We have ps, the value should be 5, add rule. We have 0, and then the value should be 0. Click on add rule. The value over here should be ns, and minus 5 over here, so add rule. Nm and minus 50 over here, add rule. Nb minus 100 over here, and then add rule. So we've completed 4 rows now. The fifth row is with respect to positive small. So select positive small, and we will be starting off with PB again. So it starts from 100, add rule, PM 100, so add rule. Then you have PS, that is 50, add rule. Then you have 0, that is 5, add rule. And then NS is with respect to 0, add rule. And then NM is with respect to minus 5, so add rule. And NB is with respect to minus 50, so add this as well. So I hope you are understanding the logic with respect to adding these type of rules over here. So that is basically done based on the table that I am referring to. So again, now this should be PM, and this should be starting off from PB, and the value will be starting from 100. So scroll down, add this rule. This should be PM, and value should be 100. PS, value still should be 100. 0, the value should be 50. Then ns, the value should be equal to 5, add rule. Nm, the value should be equal to 0, add rule. Nb, the value should be equal to minus 5, add rule. So once this is done, we are left out with our last block, that is pb. So with respect to pb, the error values are starting from again pb, and the value should be equal to 100, so add rule. This should be equal to pm, add rule. Then ps, add rule. Then you have 0, add rule. Then you have ns, that is basically 50, so add rule. And this is nm, which is basically 5, add rule. Nb, which is basically 0, add rule. So we have 7 rows basically, and we have 7 into 7 cross matrix, which is basically 49 rules that is defined in this particular fashion. So once rule is defined, we can click on close. All of these rules are defined now. So in case you want to double check, you can double click on it and cross verify. Now what should we do? Now we have to export this to a file. Save it in a specific folder that you would like to, and click on save. So this file name should be this file name plays a very important role, should be carefully made a note of, and this file name is what we are going to enter in the fuzzy logic controller. So you can just reduce this, and I'll be going to MATLAB Simulink now. Click on Simulink. Alright, here we are in MATLAB. So now let us search for the components that we want by clicking on Simulink library browser. At the first place, we will be requiring a PowerGuve block. So search for PowerGuve and add that. We'll be requiring a voltage measurement block as well. Add that as well. So PowerGuve block is basically used as a compiler. So it will help the circuit to run during the compilation process. So if you don't use a PowerGuve block, then consequently it will be throwing you a simulation error. So be very careful with respect to it. So once that is done, we will be requiring a DC voltage source. So search for DC voltage and scroll a little down. So you'll be having DC voltage source here. So choose the ones that are there in black, because the blue ones are popularly used in signals and systems and digital signal processing applications. So once that is done, I will be requiring a series RLC branch. Search for series RLC and add that block. Apart from that, we will be requiring a MOSFET, which is used as a switch. You can go for IGBTs as well. The reason why we are not using thyristor is because thyristors are requiring additional commutation circuits in DC supplies. As a result, we'll not be going for it. So once that is done, we will be requiring a diode block. So search for diode, and it will be available right over here at the bottom. So add that block as well. So apart from that, we will be requiring a scope in order to see the nature of output waveform. Search for scope and add that block as well. So we will also be requiring a constant block. This is with respect to the feedback path, that is for establishing a closed loop system. So we'll be requiring a constant block. Search for constant and add that. We will be requiring a sum block in order to compare it with reference value, that is the constant value. So search for sum. You will be getting various categorical classification. We'll be using subtract block over here. So once that is done, we will be requiring fuzzy logic block. So search for fuzzy logic and you'll be getting a fuzzy logic controller. We're using this one, not this one, because again we have already defined the rule. We have to only add that file over here. So add that block. We'll be requiring a memory element. I'll tell you the reason why this is used. Search for memory and add this block as well. We will also be requiring a multiplexer. Search for mux and add this block as well. Apart from that, we will be requiring a relational operator, and we will also be requiring another block, which is called as repeating sequence. Search repeating sequence. I'll be telling the purpose while connecting these blocks. So once all of these are done, we will be placing these components in respective positions so that we can get started with respect to the circuit simulation part. So now the diode is to be placed over here, and supply in this particular position, and a voltage source at this point. So with respect to the circuit, we will be requiring an inductor, the value of inductor. So detailed design procedure I have already explained in one of my previous video. Please to watch it. It will give you a clear understanding on how to choose each and every value, and that is very very important while designing any circuits. So I'll be connecting the inductor in this particular fashion. Apart from that, rotate the diode, double click on it, and rotate the MOSFET, sorry, and double click on it and disable the measurement port. So we're not requiring a measurement port. In case you want, you can definitely use that. Double click on this as well and disable the measurement port over here. So once this is done, I'll be connecting it between these 2 points. I'll be requiring a capacitive low filter. So copy paste this, rotate this using Control R, and select capacitor. The value of capacitor is chosen to be equal to 220 microfarad. So enter 220 over here. So click on OK, and again we will be using a resistive load. So you can try it for different loads as well. Again, the nature of design will change based on the loads that are used. I'll be using a 20 ohm resistor. Click on OK, and I'll be connecting it between these 2 points. a voltage source is to be connected between these 2 points in this particular fashion in order to measure the output voltage, and I'll be giving it to the scope. So open loop simulation of this is complete. So only thing is I have to enter the supply voltage, that is basically 24 volt, click on OK. All the other parameters are already given through each and every components that I used. Now let us rotate this in this particular fashion, and let us have the some subtract block over here, rotate it as well, and let us give it to this point, and let us give it over here. Now once that is done, I will be requiring another subtract block. So control C, control V, I'll be placing it over here, and I will be requiring a memory element as well. So whatever value is obtained, so this is the error, isn't it? So error will be given to this particular block, and over here what I'll be doing is the memory element is used so that it holds the previous value. So this will give you the change in error, this will give you the error, it will hold the previous value of the error as well. So memory is used to hold the previous value. So the error and change in error, both of them are given as input to the fuzzy logic controller. So rotate this. So we have two inputs. How do we give it to one input terminal of fuzzy logic controller? That is not straightforward, isn't it? So we will be using a multiplexer, and I will be giving the one of the error input at this point, the change in error input at this point, and I will be giving it to the input terminals of the fuzzy logic controller. So fuzzy logic controller will basically have two inputs, that is the error and change in error, that is already defined in the fuzzy logic rule, and we are exactly getting the same over here. So once this is done, double click on this. Over here you have to be very careful, whatever file name was given there, so same file name should be entered over here. So I had given MPPT as the file name, so click on OK. So it will basically import the rule that is defined earlier, and it will act according to the rule that is defined. So double click on this, and you can change this value over here. So how do we change this? I will tell you. First enter the time values as I write. So the time values will be 0, 0.5, and then 1, and it will be divided by 1000, and this will be equal to 0, 1, and then 0. So what is this actually? This is actually a triangular wave. I am trying to create a triangular wave using repeating sequence. So how did I do that? So if you carefully observe, what are the time values? 0, 0.5, and 1. So if you consider x-axis as time, carefully observe the cursor movement. So a triangular wave starts from this point and goes to the peak value, comes back to this point. So if I assume it starts at 0 and goes to a peak value at say 0.5, that is t by 2, so I'm entering 0 0.5, and comes back to this point at say equal to total time t, so that is what is taken as 1, divided by 1000 in order to convert it by millisecond into milliseconds. What are the output values? 0, 1, 0. So now again observe the cursor movement, it will start at this point, triangular wave goes to a peak value, starts from 0, goes to a peak value at 0.5, the peak value will be 1 and comes back to 0 again. That is why it is 0, 1, 0. I hope this logic is clear. So this is basically just like SPWM technique, comparing the output value of the signal, the reference signal, with a carrier wave that basically has a triangular waveform in nature, and consequently the output that is produced will be in pulses form, and that will be given to the gating terminals of the MOSFET switch. Over here I have to enter the value of output voltage that I want. It should be increased to 48 volt. So click on OK. So once that is done, one of the most important things to remember is change this to discrete, because at times continuous domain, it takes a lot of time to simulate. Select the simulation time to be equal to 1 second or 0.5. I'll be selecting 0.5 over here. So these are static loads, isn't it? So we don't want such a huge amount of simulation time. So click on run simulation now. So it does take some time to simulate. We have to be a little patient while simulating it. So now you can stop the simulation. It's pretty much sufficient, I believe. So double click on the scope in order to see the waveform, and you can zoom in a specific portion of the waveform. So if you carefully observe, so it is varying totally, and the approximate value of the output voltage average, if you consider, it is a 46 volt, close to what is expected. So you can still go on with an accurate design by selecting suitable value of a capacitor filter in order to remove the ripples that is there in the circuit, and consequently get better results. So you can change the load and try it for different values, say equal to 30 ohms if I try. So you should still be getting the same nature of output voltage, and if you are you're getting that, then consequently a closed loop operation is achieved, and that is why we use these type of circuits. If there is sudden change in load, there should still be the same amount of voltage that is there at the output terminals without any deviations or drops that is there. So now let us again check the waveform by double clicking on the scope. So if you carefully observe, we're still getting the same pattern of waveform that we got previously. It is still plotting. However, if you see, the average value is approximately 46 to 48, somewhere around 47 over here. So this is exactly what is required, and we are getting that. So I hope you were able to simulate fuzzy logic based boost converter in MATLAB. In case you have any questions, feel free to reach out by typing in your questions in the comment section below. If you like this video, please do like it, share it, and subscribe to our channel for regular updates. Thanks for watching this video. Meet you guys in another video. Thank you.